Bernoulli's equation. Here, consider a steady flow of fluid through the tube as shown in the figure. The tube is with varying cross-sectional areas. Left end of the tube, that is at height h1 from the reference surface, and right end of the tube, that is at height h2 from the reference surface. At left end of the tube, the pressure is P1, velocity of the fluid is V1, and the cross-sectional area is A1. At right end of the tube, the pressure is P2, cross-sectional area is A2, and velocity of the fluid, that is V2. Okay. Now see here. Suppose we think about the fluid which one is passing through this cross-sectional area A1 with velocity V1. That will cover the distance V1 into delta t in time interval delta t. Now, in the same time interval, suppose here the fluid is displaced from D to E, means at other end the fluid cover the distance equal to V2 into delta t. Okay. Now, here at left end, if the displacement of the fluid, that is V1 into delta t, and now the force on the fluid, that is P1 A1, because pressure, that is force upon area, so force, that is pressure into area. So force acting on the fluid, that is P1 A1, displacement in time delta t, that is V1 delta t, means the work done at left end, that is W1 equal to force P1 A1 into displacement V1 delta t. But A1 V1 delta t, that is the volume of the fluid passing through this cross section in time delta t. So we can write that is P1 into volume delta V. Now at right end of the tube, say it is at height h2, and here h2 is greater than h1. It implies that the pressure on the fluid, that will be here in opposite direction of its flow. Now force, that is P2A2, displacement of the fluid, that is in this direction, and force due to the pressure, that is in opposite direction. So we can say work done at other end of the tube, W2, that is P2A2 V2 delta T, and here displacement and force are opposite, so we have to introduce negative sign. But A2 V2 delta T, that is the volume of the fluid passing through cross section A2 in time interval delta T. But here fluid is incompressible. So volume of the fluid passing through this cross section or this cross section in time interval delta t, that will be same one. So here we can write A2 V2 delta t, that is also delta V. Now total work done, that is W equal to W1 plus W2. So P1 delta V minus P2 delta V. So we can write P1 minus P2 delta V. But as per work energy theorem, this total work done, that is equal to change in energy. Now see, change in potential energy of the fluid. Suppose here the fluid flowing through this cross section A1 in time interval delta t have the mass m and the same mass of the fluid passing through A2, right? So we can say this thing, mass m of the fluid, which one is at height h1, is transferred to height h2. So at height h, the potential energy of mass m, that is given by mgh, that we studied. So we can write change in potential energy of the fluid, that is mgh2 minus mgh1. mg common ले लिए, then mg into h2 minus h1. But what is the mass of the fluid? So mass of the fluid, that is volume into density. We already calculated the volume, that is delta V, into density rho. So mass is replaced by rho into delta V, G as it is H2 minus H1. So this is the change in potential energy. Now change in kinetic energy. At left hand the velocity is V1. At right hand the velocity is V2. So we can say change in kinetic energy of the fluid, half m v2 square minus half m v1 square. Half m is taken common, so we can write change in kinetic energy, that is half m v2 square minus v1 square. But mass, that is density into volume. So change in kinetic energy, that is half into rho into delta V into V2 square minus V1 square. Now, as per work energy theorem, total work done, that is change in total energy. So, total work done P1 minus P2 into delta V, that is equal to change in kinetic energy half rho delta V into V2 square minus V1 square, plus change in potential energy rho delta V H2 minus H1 into G. Delta V will be cancelled from both the side. So on left hand side, P1 minus P2, that is half rho V2 square minus V1 square plus rho G into H2 minus H1. Therefore, P1 minus P2 equal to, now simplify this one, half rho V2 square minus half rho V1 square plus rho G H2 minus rho G H1. Now, take the terms with 1, 1, 1 on left hand side and the terms with 2, 2, 2 on right hand side. So we can write P1 plus half rho V1 square plus rho GH1, that is equal to P2 plus half rho V2 square plus rho GH2. Now, if we consider height H1, height H2, then in this way, if we consider n heights for this particular fluid flow, then we can write this type of n equations. But when all are equal, it implies that in general now we can write P plus half rho V square plus rho GH, that is equal to constant. And this equation, that is known as Bernoulli's equation. Clear? See, from this Bernoulli's equation, you can understand this thing for the horizontal flow. Now, if we take the flow is horizontal, then H1 equal to H2. So, a rho G H1, rho G H2 cancel થઈ જશે. So, simply you can write P1 plus half rho V1 square equal to P2 plus half rho V2 square. Half rho, that is constant one. તો આનો meaning એ થયો કે in horizontal fluid flow, where the pressure is more, velocity will be less. And where the pressure is less, velocity will be more. અથવા તો બીજી રીતે એવું પણ કહેવાય કે in the horizontal fluid flow, the point where the velocity is more, pressure will be less. And the point where velocity is more, pressure is less, then where the velocity is less, pressure is more. Clear? Now see, if the fluid is at rest, if the fluid is at rest, it implies that the velocity that is zero. So in this equation, we can take V1 that is equal to V2 that is equal to 0. So simply we can write P1 plus rho g H1 that is equal to P2 plus rho g H2. So we can write P1 minus P2 that is rho g H2 minus rho g H1. So P1 minus P2 that is rho g H2 minus H1. So you can find the pressure difference between 2 points in the fluid, which one is at rest, which are at height difference of H2 minus H1, will get the pressure difference. Now in this particular equation, we can say P that is the pressure, then half rho V square. Actually rho that is density. Density is mass per unit volume. So we can say half rho V square, that is kinetic energy per unit volume. Similarly here, rho gh, but after all rho that is the mass per unit volume. So we can say rho gh, that is potential energy per unit volume. Clear? So in 1 mark, if the question is that give the dimensional formula and unit of kinetic energy per unit volume or potential energy per unit volume, then directly you have to write the dimensional formula and unit of pressure, because all will have the same dimensions and same unit in this particular equation. Now Bernoulli's equation, that is P plus half rho V square plus rho GH, that is equal to constant. Now divide this equation throughout by rho G. So P by rho G plus half rho V square by rho G plus rho G H by rho G, and that is equal to constant upon rho G. But rho and G both are constant, so constant upon constant, that is some constant again. Here rho G cancel, so only H will be there. Rho cancel, so you will get V square by 2G, and here P by rho G. Now for this equation prepared here, this first term P by rho G, it is called pressure head. This V square by 2G, that is called velocity head, and H, that is called elevation head. તો આવી જ રીતે તમને જો એવું પૂછે કે give the unit and dimensional formula of pressure head or velocity head, તો તમારે શું લખવાનું? યુનિટ મીટર જ થાય અને ડાયમેન્શનલ ફોર્મ્યુલા m0 l1 t0, કારણ કે આ ત્રણે ત્રણ ટર્મ સમેશનમાં છે. તો જે h ના, h એટલે હાઈટ થઈ, તો h ના જે ડાયમેન્શનની યુનિટ હોય એ જ બાકી બે ના હોય. એટલે આવી રીતે ગણવા બેસવાની જરૂર નહીં કે ભાઈ p ના ડાયમેન્શન્સ આ, રો ના આ, g ના આ, ને પછી એને સોલ્વ કરો. ડાયરેક્ટ આન્સર આપી દેવાય. Clear to all of you?